Hey guys, this video is about solving radical equations. There's a pretty set plan that is fairly easy to follow for solving them. First step is going to be we want to isolate the radical. So like on this first one, what I would do is I would add the 1 to both sides because I want to get the radical by itself. And so that would equal 5 over here. And then I want to square both sides of the equation, because I can, add, subtract on both sides, multiply, divide, so I can also square. I'm squaring to undo the root, and that's going to let me get at the x. So here, square undoes root, and I get 2x plus 3, and that equals 25. And then if it's a linear equation, I want to get x's on one side, numbers to the other. So this is linear, so I want to strip all the numbers off of this. So we'll just do minus 3, minus 3. That'll get us 2x equals 22. Then dividing the 2 on both sides, looks like x equals 11. So in the last step, and then if it had been quadratic, I would have got it in this ax squared plus bx plus c form. In other words, descending order set to 0, and then factor and solve from there. And we'll see some of those a little bit later. The last thing we have to do is we have to check all solutions to make sure that we don't get a square root equaling a negative number. And the reason for that is if I have a square root equals a negative, so say I have square root x equals negative 2. If I let x equal 4, it would equal 2. If I let x equal negative 4, it would not exist until the next section, but it wouldn't equal negative 2. So the only way I can make this be a negative 2 is to invent a magical minus sign and throw it out front here, which we don't get to do in math. No magical minus signs. And yeah, so this is just it does not equal that. So you just can't have a root equal a negative number is the deal. Smallest thing the root can equal is 0, because square root 0 is 0. But square root negative 1, we're going to find out, is going to be imaginary numbers. It's kind of a whole other chunk of numbers coming up in the next section. So if we run into this, we have to just throw out that solution. So if I put this 11 in just to check, you have to check it prior to where you squared both sides with the root intact. I actually kind of like checking it at the second line. I should probably check it at the first, but I'm going to check it at the second. So 2 times 11 plus 3 equals 5. And I like this line just because then you can see if this number is negative really easily or not. So this is 22 plus 3, that's 25. Square root 25 equals 5, so that checks. So this next one, if I missed that this is of this form where it equals a negative number, I would go square both sides. I'm not sure if this is picking up my cat just having a fit, but it's very loud. Anyhow, so squaring both sides. So if I missed the negative and I went ahead and tried to solve it, I would get x plus 3 equals 16. I'd move the 3 over and get x equals 13. But then when I go to check it, here's what would happen. So 13 plus 3 equals negative 4. I get square root 16 equals negative 4, and it doesn't. That's 4 equals negative 4. So then it doesn't check, so 13 isn't a solution. And so then we know that this is no solution. But the easiest thing is right off the bat, before you even squared it, if you notice you have root equals a negative, it's no solution. So this next one's a cube root. And so to undo that, I would just cube both sides. And with the cube roots, we don't have to check, or for any odd roots, we don't have to check solutions for extraneous solutions. So the reason is, if I have negative 2 equals 2 and I square both sides, the problem is, and that's how we're solving these, is squaring both sides, then this becomes 4 equals 4, and I get a true statement. So I can take something false, square both sides, and make it true. But if I do the same thing with the cube, I get negative 8 equals 8, and it doesn't get it doesn't get me a true statement. It doesn't give me like that fake right answer that isn't really right when you check it. So for the odd roots, we don't have to check. For the even roots, we do. So yeah, we'll just kind of do this with. So I'm going to cube both sides here, and that's going to give me 2x minus 4 equals 2 cubed, which would be 8. I'll add the 4 to both sides, and 2x equals 12, and then divide the 2, and x equals 6. The next 3 would be ones I would have you guys try. So hopefully this first one you just looked at and went, no. It's going to be a no solution because I can't have root equal a negative number. So down here on this one, we'll add the 4 over. And then we have square root 3x plus 1 equals 5. And then from there I can square both sides. And that gets me 3x plus 1 equals 25. And then just take everything away from the x. So 3x equals 24. And then dividing x equals 8. And if we throw that back in here, I get 3 times 8 is 24 plus 1 is 25. Square root 25 makes 5. So that does check. This one's a 4th root, so we do have to check it, because even roots we check. So I'm going to raise both sides to the 4th power to undo the 4th root. So that would just leave me 4x plus 1 equals, that would be 81. Subtracting 1, 4x equals 80, and then divide the 4 on both sides. And x equals 20. And if you put that in, you'll get the same 81 right back out, and it does check. Okay, so number 7, so we're going to isolate the root first, so we're going to subtract the 10 on both sides. And so that's going to give us the square root x plus 10 equals x minus 10. And then we can square both sides to undo the root. And we have to be careful to square the whole side over here, not like the pieces, or not at all. So we square one side, we have to square the entire other side. So this undoes the root. So I got my x plus 10. And then this, I'm using that shortcut FOIL, so it'd go x squared, 2 times 10 would be 20x. And 10 times 10 would be 100. So this one came out quadratic, so that means I want to get everything over to one side. So I'm going to solve so I have a positive x squared term, just because it makes it easier usually. Okay, so now this gets us 0 over here. X squared minus 21x and minus 90. So we're looking for two things to multiply to be negative 90 and add to be negative 21. And those would be minus 6 and minus 15. Add to negative 21 and multiply to be positive 90. Sorry about that. And so x could be 6 or x could be 15. And so if we check, and like I said, I like to check this line just because it makes the negative pop out really easy. So if I put the 6 in, it's 6 plus 10 equals 6 minus 10. Right there you can see there's a problem. So that's going to be 16 equals negative 4. Nope. So that one doesn't work. If I throw the 15 in, then it keeps this side positive, so that's going to turn out. So square root 25 equals 5. So that's the one that works. And it can be they both work, it can be that neither one works, or it can be one works. So you just have to check both and see. So for number 8, this one is a root equals a root. So what I can do there is just square both sides just as it is. And then I get 4x minus 7 equals 2x plus 3, so I just get the stuff underneath the roots. And then I can bring the 2x over. And then I can add the 7 over. So on this side we're left with 2x, 7's cancel, 2x's cancel, over here equals 10, divide the 2, and it looks like x equals 5. And if I toss that in, I get 20 minus 7 so on this side. On this side I'm going to get 10 plus 3, and that's root 13 equals root 13. So that one checks. You guys try. So this one, it's already isolated, so we can just square both sides. So you just have to do like that. So squaring does root, and I get x plus 6. Over here I get x squared plus 8x plus 16. And then I'm going to bring the x and the 6 over. So those are gone. I got 0 equals x squared. 8 minus 1 would leave me 7x, and then plus 10. And so now I got it set to 0, so that means I can factor and solve. So this is going to be x plus 2, x plus 5, multiply to 10, add to 7. So x could be negative 2 or negative 5. So you can see if I put negative 5 in, it's going to make this negative, so that one does not work. If I put negative 2 in, let's check that one the rest of the way. Plus 6 equals negative 2 plus 4, so that gets me root 4 equals 2. So this one does check. This one's similar, so the first thing we do though would be to add the x over to the other side. So that'll give us square root 5x minus 1 equals x plus 1. And then from there I can square both sides. Yes, square. So then squaring both sides I get 5x minus 1, and this is x squared plus 2x plus 1. And then I'm going to move the 5x minus 1 over. So minus plus, being distracted by a cat. So this is now 0 equals x squared minus 3x I square plus 2. So factoring, I get what multiplies to be 2 adds to be negative 3. So x minus 1, x minus 2. So solutions are x equals 1, or possible solutions x equals 2. And in this case, they both end up checking. So if I put 1 in, I get 5 minus 1 is 4 on this side and 2 on this side, so that works. This would be 10 minus 1 would be root 9 equals 3, so that works. So those are both good. So for 11, this one is a little bit different. This one has 2 roots, and it has that extra number, and that messes up everything. So what we're going to do here is we're going to square both sides, but unfortunately that means I have to do like this on that side, and that's that FOIL that we were just doing a section ago. So here squaring does root, and I got x plus 5. Here I'm going to, for the sake of space, I'm going to do this as the a squared 2ab b squared version, but you can also write them side by side and do out your FOIL steps. So this is going to be square root, and then squared is x minus 3, and then 2 times a times b, so that'll be 2 times 2 is 4 times the root. and then 2 times 2, that'd be 4. So now what I want to do is isolate the radical. So I think I will, well, first off, I can cancel these x's from both sides. And I think I'll collect like terms. So 5 over here, and this is 4 and then negative 3, so that's a 1. And that'll be plus 4 and then root x minus 3. And then I'm going to move the 1 over. So now we have 4 equals 4 x minus 3. And then I'm going to divide that 4 out. Just because that will make it a little bit simpler. And so then that gets me 1 equals x minus 3. So square both sides. Square, dude. 1 equals x minus 3, and then add the 3 over. 4 equals x. And then if we go back and check that, then we get 4 plus 5 would make 9 equals 4 minus 3 would make root 1 plus 2. So that's 3 equals 1 plus 2. It sure does. So that one checks. And then this last one I have you guys try. So we would just square both sides. And again, you can write these side by side and do it as a FOIL. I prefer the a squared 2ab b squared thing, but that's just me. So here I'm going to square undoes roots, so that's going to be x plus 3. And then this is a squared, so that would be just plain x. And then 2ab, so 2 times 3 would be 6 root x. And then 3 times 3 for 9. So if I bring the x over, oops, minus, and I bring the 9 over, so then the x's cancel. 3 minus 9 would be negative 6. Those canceled, so negative 6 equals negative 6 root x. And then I can just divide the negative 6 on both sides. So that means 1 equals root x, square both sides, and then x equals 1. Then if I go to check it though, 1 plus 3 equals root 1 minus 3. So I get square root 4 equals root 1 minus 3, or 2 equals negative 2. So it doesn't, so it is a no solution.